Hey, hi guys, welcome to my YouTube channel. So myself Rohit. So I have already said you a brief introduction about myself. So let me make it quickly. So I am an enterprise wireless engineer. So my engineering background is from ECE. So I have already qualified, cleared gate examination twice and also other competitive exam. So in this lecture, let's start about the semiconductor physics. So semiconductor physics, which is nothing but the extended version that you have studied up to your school days, like in high schools that you guys have studied, right? Charges and other things. So just an extended version that we are going to cover. So from these kind of basic start, you guys will be able to get a clear more understanding of these things. So before getting into charges, mass and those things, let's start from the basic. So what is responsible for the things that we are standing in earth? So we are standing in a surface, right? So we know that gravity is the thing responsible for us to stand in this earth. So there is two kind of things that will be acting. So if you consider this as a road, so let's take this as a road. So if a man or a car is walking, for an example, if a guy is walking, then what kind of force that he may expect? So there will be friction between him and the ground surface. So there is a friction. So this is one kind of force that is acting him in order to avoid the fast movement or any kind of thing. So this is one kind of force that is acting on us when we are in contact with the earth. So for an example, if a car is flying, for an example, let's say if a car is flying, then what will happen? The gravity will come into existence. So here what kind of force will act is the gravity. So which is basic thing we already know, right? So friction, gravity, these all are one kind of things which is responsible for us. But there is another one in-depth question behind this. So friction and gravity both is acting. What is fundamental behind these two forces to act? There is some common thing which need to be behind this for these thing to get exist. So that is called mass. Okay, so mass is the fundamental property. It's a very important start for all the thing. So here the man will have some mass or the car will have some mass. So that is the fundamental for these two guys to trigger. So similar to that, in semiconductor physics we are also going to see about the mass and charges. So mass, as we discussed, it is a very fundamental property, so which is nothing but a fundamental property of everything, like us or in electrons or anything. It's a fundamental property of an object. Let's take it in a whole way. So as an, let's simply make it as object. So which will be fundamental thing which is responsible for gravity, force of attraction, anything. So similar to that, charge is an another kind of inbuilt inbuilt thing which each mass will possess. So charge is the fundamental property of a particles. So which is nothing but a fundamental property of particles. Fundamental property of particles. For an example, if there is two same kind of charge, so these things we already know, right? So there will be a repulsive force. So this will be repulsive. So if there is two kind of opposite charges, there will be attractive forces. For an example, here there is a minus q and here there is a plus q, means there will be attractive force. So these kind of attraction and repulsion is behave because of what? The fundamental property of charges. So similar to that, there is another, these mass and charge can be extended into another topic. Like we already know that electrons are revolving around the nucleus. So we in the beginning days there are many debate and many other things are happening. Debate are happened there. So why the charges are not falling into the nucleus? So these I will explain this in another lecture very detailedly, like from the scratch what are all things gone and how all are it's got clarified. So here let's take a simple example. If a charge is revolving, for all the revolving there will be a outside force which will be acting, which is nothing but a centrifugal force. So centrifugal force will act. There will be another attractive force from the nucleus which is lying inside, so which is nothing but a centripetal force. Okay, so this is nothing but the radius of the outer orbital, or let's take it simple. So this is how the electron will be revolving here. There is a dot is an electron. So we know that in an ideal world, all the summation of force will be equal to 0, because charge can either be created nor be destroyed, right? Similar to that, we can extend the thermodynamics law to this force also. So here what we can do is that the centripetal force and centrifugal force summation will be equal to 0. Centrifugal plus centripetal. These charge will also be equal to 0. So we know that centrifugal force formula will be mv square divided by r, plus the centripetal force is nothing but a charge of attraction. So here we can take the charge will be as positive q. So we can consider this to be plus q into minus q divided by 4 pi epsilon naught r square, which is equal to 0. So if we these move this particle to the side, and we and these are into the opposite side, we will get a simple formula mv square, which will be equal to, for a conventional, let's take q as a e, so which is equal to e square divided by 1 r will be cancelled, so 4 pi epsilon naught into r. Okay, this is one equation. So let's make this as a equation number 1. So let's, in a series of lecture, I will be relating this equation into further more things. So this is one kind of thing. So we know that for everything, every object which is standing at a height or some kind of potential, there will be two kind of forces, two kind of energies will be possessing. So one is kinetic energy and the another one is potential energy. So this is nothing but the total energy possessed by electron. Total energy by electron. Okay, so we know that the kinetic energy formula which we apply to of mv square, and potential energy formula is nothing but the charge of attraction. So here we can make it of E minus square divided by 4 pi epsilon naught r square. Charge of attraction, but with the r only, is a radial distance of electrical potential energy, which is not a normal potential energy, it is an electrical potential energy. So which is nothing but energy at the transition level. So if we relate these formula and we could apply another one equation, like we have the mv square equation, right? So let's substitute that here. So of that equation will be equal to e square divided by 4 pi epsilon naught r minus e square divided by 4 pi epsilon naught r. So which will be getting is the of e square. Here there is 1 by 8, 1 by 4. So which will be 8. So 8 epsilon naught r, which is nothing but the energy of an electron at each band. So this is the ET. So this equation you guys have studied plenty of time, but this is for the derivation it's come. So based on the energy level, like n is equal to 1, n is equal to 2, these energy levels will change. Just we need to add n here. So n is equal to 1 we have taken here. If n is equal to 2, then we have to add another one. So in order to make this into the energy equation. So let's finalize this one. So ET, which is equal to of E square divided by 8 pi epsilon naught r, which the unit will be joule. So let's make this as a equation number 2. So in the next lecture I will even relate these two, and I will make another one formulas for the physical significance study. So I think from this basic introduction you came to know about what is the energy possessed by electron at each band, and what is the fundamental charge particles, mass, electrons and energy, what it's possessed. So in the series of lecture we will be going depth into each concepts. Thank you.